Okay, so today we're going to be solving systems by substitution. This is going to be our first day. Our content objective is students will be able to solve a system of two equations by using the substitution method. Language objective is students will be able to discuss ways of checking if the solution you derived is truly a solution. And why am I learning this? Well, it's important for real-world problems like finding the best value among high-speed internet providers. So the first thing is, let's talk about how we've solved systems in the past. What we've done in the past is we solved it by graphing, and we looked for where the two lines intersect. That would be our solution. So here, if I were to graph the first equation, it's already in slope-intercept form. My slope is 1, my y-intercept is -1. Starting at -1, I'm just going to go ahead and use the slope now, graph it, and there's my first line. Now this one here, there's two ways you could do it. You can graph x and y intercepts. However, I want to note that if you did use that, your x-intercept would be at 12, and you wouldn't be able to use that on this graph here. It's a little too small. So the other option would be to, of course, turn things into slope-intercept form, subtract x from both sides, and divide both sides by 3, and you'll end up with y equals -1/3 x plus 4. Here, the slope is -1/3, and the y-intercept is 4, so starting at 4, using the slope of 1/3, and there's your line. So, what is wrong with this graph? First of all, nothing's really wrong with it, but the solution is right here, and I can't accurately tell you what that point is because it's not at a nice intersection on the graph. So what do? Well, I can kind of see that it's approximately around 4,3, but that's not precise. So should you use the graphing method to find the answer to this system? No. So there's got to be a different way. And there is. In fact, there's 3 total ways. You can solve it by graphing, you can solve it by using substitution, and you can solve it by using something called elimination. So we are going to be practicing something called substitution today. So let's go ahead and try it out. Okay, so here is our very first system. It says here that 2 circles plus a square equals 25, and that a square equals 5. So we are going to be using a method called substitution today, and that's exactly what we're going to be doing. Because I know that 1 square is 5, I'm going to go ahead and substitute in this square for a 5. Now that I've done that, I've created a new equation, focusing just on this first one right here. It shows me that I have 2 circles. So 2 circles plus 5 equals 25. Now, what I'm going to be doing is simply solving. So I'm going to have to subtract 5 from both sides, leaving me with 2 circles equals 20. So what does each circle represent? It represents 10. So now that I know that a square is 5 and a circle is 10, let's double check to see if this is true. So if a circle equals 10, I'm just going to go ahead and say this is 10 plus a square, which is supposed to be 5. Is this true? 10 plus 10 plus 5 is 25, so that works for the first one. Well, here we are claiming that a square is 5, so does 5 equal 5? Absolutely. So here I can conclude that a circle equals 10 and a square equals 5 is my answer. So obviously here you couldn't write your solution as an ordered pair because it's just circles and squares, but if you did have it as x's and y's, you would definitely be able to write it as an ordered pair. Okay, so now let's take a look at the second one. It says 2 circles plus 1 square equals 18, and a circle plus the square equals 10. So again, what we're going to be doing is we're going to be substituting. Well, first, I recognize that a circle and a square can give me 10. So what I'm going to do is I'm going to replace 1 circle and 1 square for 10. Now I have a new equation. I have 1 circle plus 10 equals 18. So if I want to solve algebraically, if I subtract 10 from both sides, I'm left that 1 circle equals 8. Okay, so I know that a circle equals 8. So if this circle equals 8, then what does this square need to be? Well, it's going to have to be 2. So I'm going to claim that my circle is 8 and my square is 2. But let's go ahead and double check to see if that works. Let's see, a circle is 8. Does 8 plus 8 plus 1 square, which is 2, does this equal 18? Yep. Here, does 1 circle, which is 8, and a square, which is 2, does it equal 10? Correct. So it does work for both. So moving on to next one. Okay, so here in this system, we have that 2 circles plus 1 square equals 2, and 1 circle plus 1 square equals 4. So we need to figure out, what does a square represent? What does a circle represent? So here, I do recognize that 1 circle and a square gives me 4. So what I could do here is swap out, or aka substitute, that this circle and this square can be represented with the number 4. So now I have an equation. So in order to figure out what a circle represents, I'm just going to go ahead and subtract 4 from both sides, leaving me with 1 circle equals -2. So now that I know that a circle is -2, a square must then equal what? Hopefully your answer is 6. If you weren't sure, you could add 2 to both sides, and that's what would have given you 6. But anyways, now that I know a circle is -2 and a square is 6. But just in case, let's go ahead and check to see if this checks out. Does -2 plus -2 plus 6, does this equal 4? Well, that's -4 plus 6, which is 2, so that works. Here, does a -2 plus 6 equal 4? Check, so I'm pretty confident that my solution is correct, that a square is 6 and a circle is -2. Okay, so now let's take a look at this one here. So this one's different. We're not exactly going to substitute, but we could figure some stuff out. Here, I know that we have 3 triangles and it equals 27. Obviously, each triangle is going to be worth the same. So for this reason, since I have 3 triangles and they equal 27, I can conclude that each triangle, you guessed it, is 9. So here I know that my triangle is 9. So here, if I know that my triangle is 9, then what should a square be? Well, it should be -1. So if you weren't sure, again, you could have subtracted 9 from both sides, and that's what would have given you that a square equals -1. But if you didn't see that, that's totally fine. So here I'm going to conclude that a square is -1, but let me just double check. Does 9 plus 9 plus 9 equals 27? Absolutely. Does 9 plus -1 equals 8? Check and check. So I'm pretty confident that my answer is correct, that a triangle equals 9 and that a square equals -1. Okay, so this one's very similar to the last one. We know that 3 triangles equals 12. Therefore, we can conclude that each triangle has to equal 4. So let's go ahead and replace that these equals 4. Well, 4 plus 4 plus 4 is 12. So we know that these 3 triangles represent 12. 12 plus a square equals 15, which means that this square has to equal 3. So now I know that a square equals 3, and of course a triangle equals 4. But let's just double check to see if this checks out. 4 plus 4 plus 4 equals 12. That is true. 4 plus 4 plus 4 is 12. Plus 3 does equal 15. Absolutely. So I'm pretty sure that works. Now, some of you may have seen it a different way. Some of you may have seen, hey, look, 3 triangles equals 12. So you could have replaced these 3 triangles with the value 12. You would have gotten 12 plus a square equals 15, which therefore would mean this square is 3 as well. So either way, you could have seen it as I'm going to solve for what each triangle represents, or simply substitute that these 3 triangles is 12, swap it out, and you'll still get the same exact answer. So now we're going to move on to the next example here. Here it says that 2 circles plus 2 triangles equals 16. But we also know that 2 circles equals 2 triangles plus 4. So what we're going to do is go ahead and swap out these 2 circles in 4, 2 triangles, and a 4. This leaves me now with 4 triangles plus 4 equals 16. I'm going to go ahead and solve by subtracting 4 from both sides, leaving me with 4 triangles equals, let's see, 16 minus 4 is 12. So therefore, I would have to say that each of these triangles, since there's 4 of them, they would have to represent 3. So I can use any of these problems to help me figure out what a circle represents. I'm going to go ahead and choose this one right here. It really doesn't matter which one you choose. You want to choose something that you think would be easiest. So here I know that each triangle is worth 3. So 2 circles is going to be equivalent to 3 plus 3, which is 6, plus 4, which is 10. So if 2 circles equals 10, each circle will have to equal 5. So let me just double check to see if this checks out. 5 plus 5 is 10, plus 3 plus 3, does this equal 16? Correct. Here does 5 plus 5, that equals 10, equals 3 plus 3, which is 6, plus 4, which is also 10, so this checks out as well. So please don't forget to check your work to make sure that they are indeed correct. For the very last one, it says here that 2 circles plus 2 triangles equals 18. It does also say that 2 circles is equivalent to 2 triangles plus 6. So we're going to go ahead and replace these 2 circles with 2 triangles and a 6, leaving us with 4 triangles plus 6 equals 18. I'm going to go ahead and solve it algebraically now, leaving me with 4 triangles equals, let's see, 12. Therefore, each triangle, since there's 4 of them, has to equal 3. So I'm going to say that a triangle equals 3. Last time I used the bottom one, I'm just going to show you I can also use the first one. So I'm going to go ahead and replace these triangles with 3's. So now I have 2 circles plus 3 plus 3, which is 6. 6 equals 18. Here you can go ahead and solve algebraically and get that 2 circles equals 12. So each circle must represent 6. But let's just make sure this checks out. 6 plus 6 is 12. Plus 3 is 15, plus 3 is 18, so that checks out. Circles are 6's and triangles are 3. Does this check out? Well, this is 12 equals 6 plus 6, which is also 12, so this works out. Obviously, for your homework, you're not going to just simply put a check mark, I'm hoping. I'm hoping that you would say 6 plus 6 plus 3 plus 3 is 18. 18 equals 18. Check. Here, 6 plus 6 is 12 equals 3 plus 3, which is 6, plus another 6 is 12. So this is what I actually want to see, not just you filling it in and saying that it works, because I can't tell if you did really check or not. Okay, so that's actually going to conclude our lesson for today. Thank you so much for tuning in, and as always, until next time, bye.